Balancing equations, we always follow the conservation of mass and matter. Mass means the total mass before must equal to the total mass after in an ideal situation. Matter means the total number of atoms before must equal to the total numbers of atoms after. Conservation means that nothing can be created or destroyed. The numbers before and after must match. To understand reactions and balance them, you need to understand some basic symbols. Arrow separates the reactants from the product. It tells you that something is yielded or produced or formed in the reaction. When you see the plus, it separates the reactants from other reactants if there's more than one, and products from other products. AQ means aqueous, dissolves in water. So for example, if I put salt in water, the salt will dissolve in water. S subscript means solid or insoluble or precipitate is formed. L stands for liquid. G stands for gas or vapor. These are the basic rules for balancing. First thing you need to do is correctly write formulas for the reactants and products. If you do not write these correctly, you will have difficulty balancing. Number 2, count all the atoms of the reactants and then count all the atoms of the product. If they are not equal to each other, remember before and after has to be the same amount, then you need to balance. If they are equal to each other, then it's already balanced. Number 3, balance one atom at a time. If it's a polyatomic and they appears the same on both sides, you could keep the polyatomics together and count it as one. In general, you want to balance hydrogen and oxygen last because usually they occur as diatomics. Number 6, balance using coefficient. Remember, coefficient is the big number in front. Just like in algebra, when you write 3x, 3 is the coefficient of x. Number 7, never change the subscripts, especially for the polyatomics. 8, recount and reduce if possible. These problems, equation is already written for you, so we could skip step 1. Step 2, we need to start counting. So I'm going to separate the reactants from the products. Remember, the reactants are on the left side, the products are on the right side. So HCl, Na, and OH. I'm going to keep OH together because OH is together on the opposite side. Remember, a lot of times it's easier if we could rewrite water as HOH, and that has an H, and OH, which is the polyatomic. So it has one H, one Cl, one Na, and one OH. Remember, we kept the polyatomic together because it appears on the opposite side together. To make it easier, I rewrite the atoms in the same order to compare. I have one Na, I have one Cl, I have one H, and one OH. I have equal number of atoms on both sides, so this one is balanced. Number 2, again, I'm going to separate my reactants from my products. I'm going to count each atom. So H, and then PO4. I'm going to keep PO4 together. Why? PO4 appears here, and PO4 appears again on the opposite side together. There are 3 H's because the subscript 3, but there is one PO4. If there is more than one PO4, it needs a parentheses. Mg, there is one. Unwritten subscript is 1. And then there are 2 OHs. 2 OHs. And I kept the hydroxides together because they appeared the same on the opposite side. HOH. So I'm going to do the same thing on the product side. There is 1 hydrogen. There are 2 PO4s. There are 3 Mgs and 1 OH. So my hydrogens are not balanced. Neither are my PO4s. My magnesium is not balanced, or my hydroxide. So I'm going to balance my phosphate. To balance phosphate, there's a 2. I need this side to be a 2. Put a big number in front. the coefficient is going to be 2. So now I have 2 times 3, which is 6 hydrogen. And I have 2 times 1 PO4, so I have 2 PO4. If I put the coefficient 2 in front of phosphoric acid, it's the same thing as writing phosphoric acid twice. So if I count this, there are 6 hydrogen, just like we have this, or 2 times 3. And there are 2 PO4s, 2. We don't multiply 2 and 4. It's part of phosphate. There's only one phosphate, so it's 1 times 2. So my phosphates are balanced, but my hydrogens are not. So I'm going to put a 6 in front of here. There's 1 hydrogen, so 6 times 1. So that makes this 6. My hydrogens are balanced. My phosphates are balanced. I have 6 times 1 hydroxide, so this becomes 6. So I need to balance my magnesium and hydroxide. I have 3 magnesium on the right, so I need 3 on the opposite side. So I'm going to put a coefficient of 3. 3 times 1 will give you 3. 3 times 2 will give you 6. Now my equation is balanced. So if I have a coefficient of 3 here, it's the same thing as writing magnesium hydroxide 3 times. And so if I count this, there's 3 Mg's and there's 6, 2, 4, 6. Same thing here. If I put 6 H2O's, it's writing water 6 times. So there's 6 hydrogen and 6 hydroxides. Number 3, again, separate the reactants from the products. Reactants are on the left side. I cannot put ammonia together because it's separated. So I have 1 N hydrogen, there's 3. I have an N, there's 2 N's. H, there are 2 H's. So if I look at this, I need to find a common factor. The least common factor between 3 and 2 is 6. To make hydrogen 6, I need to put a 2 in front. When I do that, there's 1 nitrogen. 2 times 1 makes it 2 nitrogens. 2 times 3 makes it 6 hydrogens. My nitrogens are balanced. There's 2 on the right, 2 on the left. My hydrogen, I need a 3 here. 3 times 2 is 6. So my coefficients are 2, 1, 3. Remember, if the coefficient is 1, just like in math, we do not write 1x. We just write x. So here it is not 1 N2, but just N2. Pause the video, try these on your own, and then check your answer. So for number 4, I'm going to separate the reactants from the products. There's 1 C and there's 8 S's. On the opposite side, I'm going to C and S. There's 1 C and then 2 S's. My C's are balanced, but my S's are not. So I need 8 S's on the right side. To do that, I need to put a 4 in front. When I put a 4 in front, this is 4 times 1 C. That makes it 4. 4 times 2 is going to be 8 sulfurs. So my sulfurs are balanced, but my carbons are no longer balanced. So I need to put a coefficient of 4 in front. So now this is 4. Balanced equation is 4, 1, 4. For number 5, we're going to separate this again. There's a carbon, hydrogen, and oxygen. Same thing on the opposite side. Carbon, hydrogen, oxygen. There are 6 carbons. There are 6 hydrogens. And then there's 2 oxygen. If I look on the right side, there is 1 carbon. There's 2 hydrogen. And then there's 2 oxygens here, separated by a plus and a 1 here, so a total of 3 oxygen. So if I balance my carbons, I need a 6 in front here. If I have a 6 in front, this makes it 6 carbons. For combustions, it's easier after I balance the carbons to go to the hydrogen and do the oxygen last. So I have 6 hydrogens. To make it 6 hydrogens on the opposite side, I need a 3. When I do that, that's 3 times 2, that's 6. So my carbon and hydrogens are balanced. Now let's go back to oxygen. So for CO2, there are 12 oxygen available. 6 times 2 plus 3 times 1, which is 3. This is 15. This is not possible because here oxygen, no matter what coefficient I put in front of O2, it's going to be an even number of oxygen because it's multiple of 2. We need to start again from the beginning. So we know we need an even coefficient in front of water to make the oxygen even. So we're going to start with the next even coefficient, which is 2. So I'm going to put a 2 in front. That gives you 12 carbons. This gives you 2 times 6, which is 12 hydrogens. And I'm going to do the same thing on the opposite side. So in order to get 12 carbons, I need a 12 in front. That's 12 carbons. To get 12 hydrogens, I need a 6 in front. 6 times 2 is 12. Now I'm going to balance the oxygen. 12 times 2 is 24. Separated by a plus. 6 times 1 is 6. So this is going to be 30. So there's 30 total oxygens. To get 30 total oxygens here, I need a coefficient of 15. So 2, 15, 12, 6. So when you balance combustion reaction, you need to always see if the oxygens are even or odd. So you always have to look at what happens to the water. Number 6, again, I'm going to separate it, lithium. And this one, I'm going to make it into H and OH. Water, I'm going to rewrite as HOH because it appears as OH and H. 1 lithium, 1 hydrogen, 1 hydroxide. On the opposite side, repeat the procedure. Lithium, there's 1 hydroxide, 2 hydrogen. My hydrogens are not balanced, so I need a 2 in front. When I put a 2 in front, there is 2 hydrogens. There are 2 hydroxide. My hydrogens are balanced, but my hydroxide are not, so I need to put a 2 in front of lithium hydroxide. 2 times 1 gives you 2 lithiums, and then 2 times 1 hydroxide gives you 2. My hydroxide are balanced, but not my lithium, so I need a 2 in front of lithium. So my coefficient are 2, 2, 2, 1. If you do not want to break the water into HOH, you could also do it into H and O's. It just takes you longer to balance. But if you do it correctly, you'll still get the correct answer. Pause the video, balance these problems on your own, and then check your answers. So again, we're going to separate the reactants from the products. And I'm going to count nitrogen by itself because ammonia does not appear on the opposite side. Hydrogen, and then chlorine. There is 1 nitrogen. There is 3 hydrogen here, separated by a plus, and 1 here. So there's a total of 4 hydrogen, and then 1 chlorine. On the opposite side, we're going to keep the same order to make it a little bit easier. There's 1 nitrogen, 4 hydrogen right here, and 1 chlorine. So the numbers match before and after. So this is balanced. Number 8, and we're going to divide the reactants from the products. Carbon, we have sulfur, and we have oxygen. There is 1 carbon, 1 sulfur, 2 oxygen. We're going to keep the same order on the opposite side. There are 2 carbons because we have a carbon from here separated by a plus and a carbon from here. So there's a total of 2. There's 2 sulfurs and then 1 oxygen. We're going to balance carbons last because we have a carbon by itself. So let's balance the sulfurs. We have 2 sulfurs on the product side, so we want 2 on the reactant side. So we put a coefficient of 2. Big numbers. We do not change the subscript. It's 2 times 1 because there was 1 sulfur, so this is 2. And 2 times 2 because there's 2 oxygens, so this is 4. So my sulfurs are balanced, 2 and 2, but my oxygens are not. I have 4 oxygens here, so I need to make it 4 here. So I need to put a 4 in front of CO. When I put a 4 in front of CO, there are 4 carbons. 4 times 1 And then there's a carbon from CS2, total of 5 carbons. 4 times 1 oxygen will give you 4. So my oxygen and sulfurs are balanced, but not my carbon. So I need to put a 5 in front of C. So this is 5. So my coefficient are 5, 2, 1, 4. Number 9, I'm going to separate my reactants and products. I'm going to recount my hydrocarbon to make it a little bit easier. So we know it's going to have carbon and hydrogen, and then we're going to have oxygen. So there's 1, 2, 3, 4 carbons, 3, and 3 is 6 plus 4, so that's 10 hydrogens, and then there's 2 oxygens. I'm going to keep the same order on the opposite side. There is 1 carbon, there is 3 oxygen, there's 2 from the CO2, and 1 for the water separated by a plus. So this is 3, and then 2 hydrogens. So I need 10 hydrogens. If I put a coefficient of 5 in front of H2O, it gives me 10 hydrogen. However, my oxygen now becomes odd because 5 times 1 is an odd number, and CO2 is always an even. But on my left side, it's always going to be an even number. So I know the coefficient that has to be in front of water has to be an even number, because anything that is odd will give me an odd number of oxygens on the product side, and the reactant side can only be an even number because anything multiplied by 2 will come out even. So I'm going to start with the next even coefficient in front of my hydrocarbon, which is 2. That makes this 8 hydrogen, makes this 8 carbons, and makes this 20 hydrogens. My oxygen still stays the same. So the coefficient I'm going to put in front of water is going to be 10. 2 hydrogen, which is 20. So my hydrogens are correct. I need 8 carbons, so I put an 8 in front of CO2. That makes it 8 carbons, so my carbons are balanced. Now I need to recount the oxygen on the right side because my coefficients change. So 8 times 2 here is going to be 16 separated by a plus. 10 times 1 is 10. So that tells you I'm going to have a total of 26 oxygen. So I need 26 on the opposite side. So that means my coefficient has to be 13. And 13 times 2 is 26. So my coefficient for number 9 is 2, 13, 8, and 10. Pause the video, try the next 2, and then check your answer. Again, we're going to separate the reactants from the products. Fe, S, and O. There's 1 Fe. There are 2 S's, subscript 2, and there are 2 oxygen. I'm going to keep the same order on the opposite side. So there's 2 Fe's. There's 3 oxygen from Fe2O3 and 2 from sulfur dioxide separated by a plus. So there's 5 oxygen, and then there's 1 sulfur. My sulfur is not balanced. Neither is my iron. I'm going to start with my iron because my iron is combined with sulfur on my reactant side. So if I figure out how many irons I need, I will know my sulfurs. Since there's 2 irons, I put a 2 in here to make 2 irons. 2 times 1 will give you 2 irons. 2 times 2 will give you 4 sulfurs. My irons are balanced, but my sulfurs are not. So I'm going to balance my sulfur on the product side by putting a 4 as my coefficient. When I do that, 4 times 1, there's 4 sulfurs. My oxygen is 4 times 2, which is 8 from the SO2. And then I have 3 from here. So 8 plus 3 is going to give me 11, which is an odd number. But on my reactant side, it's an even number. It's not going to work out because I need even numbers of oxygen. To make the oxygen even, I know my Fe2O3 has to be an even number. So we need to make Fe2O3 an even number. To do that, after coefficient 1, to make it even, I use 2. Put a 2 as my coefficient. 2 times 2 will give me 4 irons. So I'm going to balance the irons on the opposite side again, because the iron and sulfur are combined together, which will determine how much SO2s I need. Since I have 4 irons on the product side, I need a 4 in front of FeS2. So 4 times 1 is 4. This tells you 4 times 2 is 8 sulfurs. My irons are balanced, but my sulfurs are not. To get 8 sulfurs on the product side, I need a coefficient of 8 in front of SO2. So 8 times 1 is 8. My sulfurs are balanced. Now I need to count my oxygen. 2 times 3 right here is going to be 6, plus 8 times 2, which is 16, which gives you 22. So I have 22 oxygens. I need 22 on the opposite side. So it's going to be 11, which will give you 22. So my coefficients are 4, 11, 2, and 8. Number 11, we have aluminum hydroxide. I'm going to keep together because water can be written HOH. Again, you do not have to separate water. If you want to count the H's and O's separately, that is fine. If you do it correctly, you'll still get the same correct answer. So I'm going to keep the OH together. I have hydrogen because I separated the water and there's a hydrogen. And SO4 is a polyatomic that appears on both sides. There is 1 aluminum, there's 3 oxygens, there are 2 hydrogens, and 1 sulfate. SO4 is sulfate. There's only 1 of them. I'm going to keep the same order on the opposite side. So there are 2 aluminums, there are 3 sulfate, there is 1 hydrogen, and 1 hydroxide. So my aluminums are not balanced. So I'm going to start with a 2 as my coefficient to make my aluminums balanced. So 2 times 1 is 2. 2 times 3 is 6. My hydroxides are no longer balanced. To balance it, I need a 6 in front of water. When I do that, I have 6 times 1 will give me 6 hydrogen. 6 times 1 for the hydroxide will also give me 6. So now my aluminum and hydroxide are balanced, but my hydrogen is not. I have 6 on the product side, only 2 on the reactant side. So I need a 3. 3 times 2 is 6. Then 3 times 1 is 3. Now everything is balanced. So my coefficients are 2, 3, 1, 6. Pause the video, try 12 and 13 on your own, and then check your answer. Again, we're going to break the products and reactants apart. We have carbon, hydrogen, and oxygen. There are 3 carbons right here, 8 hydrogens, and 2 oxygen. On the opposite side, we're going to keep the same order to make it easier to compare. There's 1 carbon, 2 hydrogen, there is 2 oxygens from CO2 and 1 from the water, total of 3. So to balance the carbons, I need a 3 in front. That makes it 3 carbons. I'm going to balance my hydrogen. I put a 4 in front. 4 times 2 is 8, so there's 8 hydrogens. My hydrogens and carbons are balanced. Now I'm going to count my oxygen. 3 times 2 is 6, plus 4 times 1 is 4, total of 10. To have 10 on the opposite side, I need a 5, so my coefficient are 1, 5, 3, 4. For number 13, again, we're going to separate C, H's, and O's. C, H's, and O's. There are 2 carbons. There are 6 hydrogens. There's 5 here and 1 here, so the total of 6. and then there are 3 oxygen. 1 here, separated by a plus, and 2 here. So that's a total of 3. So on the opposite side, I have 1 carbon, 2 hydrogen. There's 2 oxygen from CO2, 1 from the water. We know that we need 2 carbons, so I'm going to put a 2 in front of CO2. When I put a 2 in front of CO2, that is 2 carbons. Now I want to balance the hydrogen. I have 6 hydrogens, so if I put a 3 here, I'm going to have a 6 hydrogens. So if I count my oxygen, this is 2 times 2, which will give you 4 oxygen, plus 3 from here, which is a 7 total oxygen. So I need 7 on the left side. I already have 1 from C2H5OH, which is ethanol. So I subtract 1, so I need 6 more. So I put a coefficient of 3. So if I recount, this is 3 times 2, which is 6, plus 1 from here. So that's a total of 7. So my coefficients are 1, 3, 2, 3. If you are struggling with balancing, it's helpful to write the elements out just like we did here and count each of the elements separately. Eventually you'll get to a point in which you do not have to write the elements out and you could just balance it